Friends, welcome back. Today we are going to solve another popular and interesting question on Leetcode 2182, construct string with repeat limit. As you can see here from like dislike ratio, this is another likable and popular medium complexity coding interview question on the Leetcode. So we are going to go through this problem, understand this problem today with few examples. We are also going to implement our Java solution code to solve this coding problem. If you are new to this channel, please subscribe to this channel now. Also click on the bell notification icon button right away so you won't miss any important postings from this channel. Here we create videos to help others in their interview preparation and learning concepts, different data structures, algorithmic approaches, Java programming and learning. So let's start. You are given a string s and integer repeat limit. Construct a new string repeat limited string using the characters of s such that no letter appears more than repeat limit times in a row. You do not have to use all the characters from s. Return the lexicographically largest repeat limited string possible. A string a is lexicographically larger than string b if in the first position where A and B differ, the string A has a letter that appears later in the alphabet than the corresponding letter in B. If the first minimum A dot length, B dot length characters do not differ, then the longer string is the lexicographically larger one, right? So this is the definition of a lexicographically larger string, right? So we'll go through the examples. So repeat limit is between like 1 is less than equal to repeat limit is less than equal to s dot length is less than equal to 10 raised to 5. So the given string s can have maximum 1 lakh characters and it will contains only lowercase English letters. Okay. So let's first quickly understand what lexicographically larger means, right? So let's say you have two strings, right? You have a string AB and you have a string CD, right? So string CD is lexicographically larger than AB because this is where the first difference is, right? In two strings, C comes after A in English alphabet. So this is lexicographically larger than AB, right? So this is what the definition of lexicographically larger means, right? Okay. So we will understand this problem with the few examples. So let's take this first example over here. So this is the same example. So as you can see, the corresponding string that is given to us is CC. So let's write down this CC, then ZA, and ZCC, right? ZCC. So now we want to find out the repeat limit string where, but we want to find also lexicographically largest. So how we will get lexicographically largest string? First we have to use Z character, right? Because we want lexicographically largest. So we can use Z character 2 times. We can use the characters consecutively maximum 3 times. That is what they are saying, right? Next time, now Z is already used. Now what we should use next time? We can use C, right? Because lexicographically largest we want, right? So C is more than A lexicographically, right? So we should use C. So we will use 3 C's because we cannot use more than 3 because 3 is the repeat limit, right? So we use 3 C's. So we use these 3 C's, right? So one C is still left over, right? Now after C, we cannot use C because it will be 4 consecutive characters. We cannot use C now again, right? So we have to use A. So we will use A here now, right? We used A. Now we still have a C remaining. So this C we can put it at the end now, right? We can put the C at the end. So this is the lexicographically largest string with repeat limit. So as you can see, this is the answer, right? ZZCCC AC, ZZCCC AC, right? So this is what the problem is asking us to find. Okay, so you are getting more idea about what the problem is, I hope. So when we are choosing character, we will always choose the lexicographically maximum character, right? For example, here we will first choose Z, right? We will put Z as many times as possible here. Possible means as many times as the repeat limit allows us, right? So repeat limit is 3, so you can maximum put 3 characters, but you only have 2 characters, so you will first put the 2 characters, right? Okay. Next time after Z, what is lexicographically next character is C. So you will use C next time, right? C you used here, and this C you used here, right? Okay. After this, next time, what lexicographically next character you can use? A, right? A is available, so you can use A next time, correct? Because you cannot use C, because C will be repeated, right? So C cannot be more than 3 times, so you will have to use A, correct? And after that, one C is still left over, that you can put it here now at the end, right? So this is how you can construct this string with uh, which is lexicographically largest, and it follows the repeat limit basically. Okay, so this is what the problem says. So I hope you understood this example clearly. So how can we solve this problem? So let's take this same example over here, right? So this is the same example. So first thing what we will do is we will create a tree map from these given characters, right? So tree map will essentially will be holding character and its frequency, but it will be having the characters in descending order. So Z will come first, right? So Z appear 2 times, right? Z appear 2 times in this string. Then C will come, because why we are doing it? Because lexicographically largest we want, right? So C appear 4 times, so we'll put C 4 times here, right? And then we'll put A appear 1 time. So we'll create a map which is a tree map, right? Why it is tree map? Because it is going to be keeping these keys in sorted order. So this is a sorted descending order. So it's sorted in a descending order, right? Z, then C, then A. So this part is clear, right? You can easily create a tree map by going through characters. Um, so each character and its frequency. So this map is now ready to use. So we have prepared this map. So we'll use this map now, right? So this is a key value pair. So how we will now use this map? So we will start now with the maximum character from tree map, right? So tree map maximum character, you will get this Z. So you will put Z 2 times, right? So you put Z 2 times here. Okay. So you put Z 2 times, because maximum times you can put 3, right? After that, you will keep reducing the frequency. Frequency of Z becomes 0, right? Frequency Z becomes 0 because you used Z, right? Once it becomes 0, we will remove this, because there is no point to keep this here, right? Because you already have used that now, right? Next time we will again get the next character, which is lexicographically maximum. So lexicographically maximum available character is C. So you will get C, and you will try to put it maximum 3 times. Right now you have 4, which is greater than 3. So you will try to put C 3 times, right? Because you are allowed to put 3 times only with this repeat limit, right? You will reduce its frequency, so its frequency will become 1, correct? Its frequency became 1 now, right? Because you use 3 C's. Okay. Next time also you will keep track of what previous character you have used, right? The previous character you have used is C now, right? So we'll keep track of this also, right? So now you cannot use C because you already used C, right? So you have to use the next character which is available. The next character you can use is A, right? Because A, you cannot use C because you already have 3 C's. So next time you will use A, you will put A here. You will reduce its frequency, so it will become 0. So 0 means you don't have to keep it into the map. You will remove it, right? Okay. After that, your previous character will become A. So you already used A now, right? So next time you will have to use another character. So you can use C, right? So you can just put C here. So this way we can actually use tree map to solve this problem. So I hope you understood this logic. So first thing we have to do is we have to create a tree map from this given string. Tree map will hold character and its frequency, and it will be in a descending order of characters. So the maximum lexicographically maximum character will be on the top in tree map. Okay. Once that one is ready, then we will go through this tree map and we'll use this logic so that we can get this repeat limited string basically, which is lexicographically maximum, right? And tree map will help us in this lexicographically maximum, because tree map will keep the characters in lexicographically descending order, right? So this is how we can solve this problem. So the tree map, now you understood the logic. We'll go to the Java solution, but before that we'll have a quick look at the tree map class. To the people who doesn't know it, I wanted to quickly show them that this class is in java.util package, a tree map. It also is a map class interface implementation. Again, it's a key value pair. So the main difference between hash map and tree map is that the tree map will keep the keys in sorted order, correct? So that is the main difference. So as you can read here, a red black tree based navigable map implementation. Map is sorted according to natural ordering of the keys. So you can change this order by using, you can put it either ascending order or descending order, however you want, right? But it will follow some order of either ascending or descending basically, right? The other important thing you should know is this one, right? So the important method of tree map, some of the important methods are contains key, get, put, remove. It takes logarithmic time for these methods, right? So this one you should know. After that, there are lots of other important methods that are very important from tree map class. Some of them are ceiling entry, ceiling key, higher entry, higher key, first entry, first key, floor entry, floor key. All are important methods. You should know how to use these methods. So go through all these methods, understand these methods, last entry, last key, lower entry, lower key. So understand these methods. This is very important Java collections framework class. So I wanted to show you that it's located in Java util package. So now we will go to the Java code and we'll understand how to implement this logic that we have seen here, right? So this is our Java solution. So repeat limited string is the method we are implementing. String s is given to us, repeat limit is also given to us. It will obviously return a string, right, which is a repeat limited string. First we will create a tree map which will hold characters as a key and integer is the frequency, right, of that character. So here when we are creating the tree map, we are using collections.reverse order because we want to keep the characters in sorted descending order, right? That's why we have to use this collections.reverse order. Okay, so now this is clear to you. Now you will go through this given string character by character in this for loop and you will create a tree map, right, which is essentially a frequency map, and it will look like this. So Z2C4A1, right, this is what it will create, right? So this is straightforward. Now this is a get or default method you should know. So if you don't have that entry into the map for that character, it will return you 0, right? Otherwise it will give you the current frequency of that character and then you add 1 to the frequency, right? So string builder instance we will create here because we will be building this string dynamically. So in Java we should use a string builder when we want to build dynamic strings, right? Because in Java strings are immutable. So it's better to use string builders for building dynamic strings. So here we will start now iterating and creating our repeat limited string. So while map is not empty, right? So you will first read the maximum character which is available in the map. So how you will read it? Map dot first key will give you the lexicographically maximum character. Okay, so this is important that it's a lexicographically maximum character first. Okay, now once you get that character, you wanted to check the current frequency of that character. If it is less than or equal to limit, repeat limit, then you want to just use that directly, right? For example, this case, right, Z is 2, so you have less than 3 characters, right? Less than or equal to 3 characters, you will directly use those characters, right? So that's what you will do here. So you will go through the available frequency of that character and you will start appending that character here. The number of frequency which is available, that many times you will append, right? And after this one is done, once you used all those frequencies, you will remove it from the map because you already used it, right? As I shown you, Z, once you use it 2 times, you will remove that Z from the map, right? So this is what we will do here. Okay, so this is clear. So this if loop will happen when you have a frequency of that character which is less than or equal to repeat limit. Now there might be times where the frequency is greater than the repeat limit, right? For example, here C, right? C frequency is 4, right? So C frequency is 4. So you use Z 2 times, right? So you appended Z. Now you want to use C, right? Next time, but its frequency is 4. So it's more than the repeat limit, right? It's more than the repeat limit. So this is the case we will handle in the else block. So we will first append the repeat limit times that character to this string. So it means that we will append C here 3 times, and then we have to reduce that 3 from here, right? So we will after that this case I'll explain you in a minute, but here we will go, right? So after that we will just get the current frequency of that character here from map dot get first, and then we will subtract repeat limit, right? So 4 minus 1, right? 4 minus 3, which is our repeat limit. We use 3 times, so you will subtract 3 from this and you will get 1. So you will update the frequency of C to 1, right? Correct. So this is what we are doing here. And after that, next time now we want to use the second character, right? Because if there are some other characters present, right, after this, so you use C character. So now you still want to use other characters, right? So you cannot use C now. After that you have to use A. So you will get A basically. So how you will get A? You will have to use map dot hierarchy method, right? Hierarchy of this character first will give you this second highest character which is available in the map. So second highest, first highest is C, second highest is A in this map, right? You understood, right? Highest in the what sense? Lexicographical sense. So lexicographically C is higher than A, right? So we have already used C now 3 times. So now we wanted to use A, correct? So this is what we are doing here. So you get that second character which is lexicographically second highest character. You append that second character here and you check if this second character frequency, if it is 1, you will remove it from the map, right? Otherwise you will just reduce its frequency by 1, correct? Because you only want to use it once, correct? Right? So that why we are only using it once? Because you want to get maximum lexicographical string, correct? You want to get maximum lexicographical string. That's why you will use this A character. Even if it is appearing, let's say 4 times, you will not use it 3 times. You will only use it 1 time. Okay. So what I mean to say is, let's modify this for a second. So I'll explain this point clearly to you. So instead of this 1, if A is appearing 4 times, let's say, right, A is appearing 4 times. So first we appended Z here, then we appended C here. So Z will be removed, right? Then you appended C here 3 times, right? C, C, C. So it will be reduced by 3, so it will become 1. Now you want to append character A because you have C but you cannot use C, right? Because you already use C repeated limit times, right? So now you want to append A. So A you will only append 1 time here. This is very important, right? Even if you have 4 A's, you will not use 3 A's here. You will only use 1 A. And you will reduce it by 1, so it will become 3. Why we have not done that? Because you want lexicographically maximum, right? If you used here 3 A's, right, next time you can use C here, right, because 1 C is left here. If we would have used 3 A's here, then this is how the string will look like, A or A, like this, right? So this is not lexicographically maximum, this is lexicographically more than this, right? So this is lexicographically more than this, correct? So that's why you only will append A once, okay, only once. Even if it has more, you will not append it more than once. Okay, this is a very important point. That's why you will see that we only appended that character once here. And you will check if that is only 1 time character, you will remove it from the map because you already used it once. Otherwise you will reduce its frequency by 1 because you have used it once, correct? Okay, so this, I hope you understood this clearly. Now I explained you with example. Now we will go back to this special case. The special case is this one. When you have 4 A's there, let's say you have used all the characters in the map. Now you have only 4 A's left, right? You have only 4 A's left in the map. Everything is used. So you know that you cannot use more than 3 A's, right? So you already use 3 A's. So if map only contains A's, then obviously you cannot use any more A's because you already use 3 A's, right? So in that case, whatever your string builder has, you will just have to return that your answer. You understood, right? because you can only use 3 A's. So if your map has only A which is appearing 4 times, 6 times, it doesn't matter. You cannot use more than 3 times, right? So you only used it 3 times, that's it. You have to return that string, right? So that this is the special case basically we are handling here. Okay. So at the end, once you reach here, you have to just return the sb.to string, right? This one will give you the repeat limit restricted string, right? So this is the way you can solve this problem. So I hope I explained you all these different cases here clearly with these examples. So now we will run this code and make sure it gives us correct answer with these test cases. For the first test case, we are expecting ZZ CCC AC. So we are getting ZZ CCC AC, which is correct answer, right? And for the second test case, we are expecting BBABAA, right? BBABAA, which is a correct answer. We'll submit this code now to the Leetcode, make sure it gets accepted. And as you can see, the code is successfully accepted by the Leetcode. It is 17.53% faster on the performance side and 46.75% faster on the memory usage. These numbers are changing, so I'm not sure about these numbers, but this is one clean way to solve this coding problem using tree map, right? So I hope you like this Java solution, and you also understood this Java solution completely and this logic completely, and how we have gotten that lexicographically maximum repeated limit string, right? So I'm going to add this Java code in my GitHub repository for you and give you the link of this Java code so you can check it out. There are lots of other important algorithms and Java solutions already implemented and available there for you. Don't forget to check out the Java codes from GitHub repository. They are important ones from interview perspective and will give you good preparation for your interview rounds. If you like the Java solutions in the GitHub repository, consider giving it a star on the GitHub repository. That would be great. If you are new to this channel, there is a very important coding interview related playlist to help your interview rounds. It is called as Leetcode and Leetcode Solutions. More than 800 different varieties of problems are here to help your interview preparation and learning different computer science concepts. If you like this video, then please subscribe to this channel, give it a like to the video, share this video with your friends and colleagues so they can also watch and learn from these videos more programming and problem solving. Click on the bell notification icon button right away so you won't miss any important postings from this channel. If you are a fresher, junior level developer and you want to practice more coding problems for your interviews, there are 3 other playlists we have created to help your interview rounds. It is called as Leetcode and Leetcode Solutions, and the other 3 playlists are called as Code Forces, Code Chef, AtCoder. Go to the playlist of this channel right away, check out those interesting problems. They will be definitely helpful for you in learning new computer science concepts and more logical thinking. On this channel, you will find lots of solved coding problems which are very important varieties from interview perspective. Those important varieties includes graphs, matrices, binary search trees, breadth first search, depth first search, cadence algorithm, binary search algorithm, Kruskal's algorithm, Dijkstra algorithm, sliding window algorithm. There are lots of important data structure questions available for you on this channel that include stacks, queues, priority queues, hash table, hash map, tree set, hash set, linked hash map, linked hash set, arrays, linked list. All are important problems. Make sure you go through all of them and understand and learn them very well. If you go through those videos and problems, you are going to learn a lot about data structures, algorithms, problem solving, logic building, Java programming and coding. It will also help you learn lots of new techniques, lots of new ways of problem solving. So make sure you check out those solved problems. If you are a fresher, junior level developer planning to take Java interviews, there are lots of Java related videos we have created to help others on this channel. For example, frequently asked Java telephonic interview questions and how to answer them, Java design patterns, Java architecture, SQL programming questions to the freshers, where they will give you database tables, they will ask you to write SQL queries, where you may have to use different database concepts like inner join, outer join, aggregate operations, group by and having clauses, different where clause conditions. Everything is explained for you in those videos. There are also videos that explains important MySQL ranking and windowing functions, which are very important to solve different SQL programming questions as well. So do check out those videos as well from this channel. There are videos that discusses recently asked questions to the freshers about Unix, like Unix commands, Unix utilities, shell scripting questions. All are here to help you in your interview preparation and learning different computer science concepts. If you like the videos on this channel, if they are helping your learning process, you are learning more techniques, more problem solving along with Java programming, coding and data structures and algorithmic approaches, then please do leave your messages, your feedback, your comments below these videos. Your feedback, your messages and your comments are highly appreciated, very important and valuable for us. They increase our motivation to create more quality content videos like this one. So do leave your messages below these comments. Tell us how the videos are useful and helpful for you. If you want us to create videos about any specific computer science, Java J2E or interview related topics, then mention those topics as well in the comments section below this video so that we can create those videos for you here. Keep learning, keep coding, keep solving more varieties of coding problems, and most importantly, keep your learning process and practicing going on continuously. And thanks for watching.